So welcome everyone. My name is Vikas and I am from State University. So I've been working on this joint collaborative work in which we are trying to make a predictive model to predict the county level corn yield prediction based on the expert knowledge and historical data using the Bayesian network. So in the talk, I will talk. So the overview of the talk will be is about the motivation behind this work, the methods which we have adopted, the learning and inference which we get out of the BaseNet, and the how we have collected the data and the pre-processing which we have done. Then I will conclude with the future work about this work. So the motivation. So there are three main reasons why we are doing this work. The first is the market of the corn we have in the US. It's $79.8 billion, the market which captured by the corn. And US is also like the largest producer of corn in this world, and they export 20% of their production outside the US. So since like the market is involved and the capital is very big, so the government is forced to make good agricultural policies for the farmers who are growing corn. And also like since this work is focused right now only for the counties in the Iowa, so the data set we have is only concerned for the counties in the Iowa. The second reason is, so people trade corn as a commodity in the share market. So what happens like USDA release daily market price for the corn. So people can sell and buy the corn at like at different times at different day, and they can make profit. So as per USDA prediction, the corn price is expected to be rise by 30 cents in these coming 2 years, as you can see. So what happens like, so in the share market, if you have like more information than me, you are expected to make good profit. So this creates what we call as information asymmetry, in which someone has better information than me, so they are expected to make good profit. So to break this trend in which someone else has more information, we are trying to come out with a publicly available good predictive model, so that this could be like as similar as what the private players are making right now. So at present, we have some conventional forecasting methods. So the two types of science model and the statistical models. In science model, people try to make simulation between plant, weather, and soil, and they simulate this interaction on the computer system, and they get the data out of it. But since the interaction and the complexity is huge, it takes time to simulate. So the next method is statistical models. So people try to analyze how like one parameter affects the yield. So they are like univariate analysis. So one of the paper by Dr. Dermot Hayes, he have checked how temperature affects the corn yield, and he mentioned in his paper like if the temperature rise above 85 degree Fahrenheit, your corn will definitely gonna damage. But since like we know yield doesn't like only depends on the temperature, there are many complex interdependencies parameters which affect yield. So we need a new model which can capture the multivariate dimensionality of the data. So what kind of model we need? We need a model which can, which could include the expert knowledge. So by experts, I don't mean the data scientists. Experts are the farmers who are the real person who knows more than us, like what is good for him and for the plants. So we need the model to include the expert knowledge, and then we need the model to include the multiple parameters and the interdependencies they have. The third is the gap or missing information. So suppose like one farmer don't have information for your data set, but other farmer has. So you have to like you have to fill the gap for the other farmer. The fourth one is your model should give a confidence interval, like how good is your model? Because like farmer knows, like so farmers want to know how good you can predict about his crop yield at the end of growing season. So just to give you an overview, so suppose like you have temperature as a variable, you have soil condition, you have monthly rainfall, then you have wind speed, then you have crop management practices. So consider this as a graph in which you have interdependencies between each other. So and your final variable is at the end, which is the county level corn yield prediction. So this is a graph in which you have directions, you have the dependencies between each other. So to solve this problem, we are using a Bayesian network approach, which is a probabilistically directed acyclic graph. So just to give an example, like how BaseNet works. So suppose like your grass is wet, and this can happen because of two reasons. Either it's raining, or either the sprinkler is on. But based on your expert knowledge, you also know rain affects whether the sprinkler will be on or will be off. So since you have the knowledge prior to making this model, you will put up a connection between rain and sprinkler. So which says rain influence sprinkler. So when you pass the training data to this model will give you a conditional probabilistical table for each of the parameters, which will say, okay, if rain is true or the sprinkler is false, what is my probability of having grass is being wet? So at the end of this, you get a confidence interval of like what is the percentage of my grass being wet because of these two reasons. So in the BaseNet, there are three main parameters which are very important. The first one is structural learning. By structural learning, I mean you can, prior to making this model, you can include some connections like which says, okay, the temperature affects soil condition or rainfall affects your drought. So you have some expert knowledge which you can use in the structure itself. And the second point is parameter learning. So you want to learn, so you want your model to learn the connections and the weights they have in between between the parameters. The third one is like the inference. So you can ask some questions to your model. What would be my yield if I have like this much rainfall or this much? So if my soil has this condition, what would be my yield at the end of growing season? Or you can also ask some reverse question. So given my yield, what would have been my weather condition in the past? So you can like ask reverse and forward questions to this model. So for this work, we have collected the data for 19 counties of Iowa, and these are some of the data sources from which we have collected. They all like publicly available. So we have like lots of parameters, but we went to the farmers. We asked them what are the 5 most crucial parameters which you think affects your plant or your yield the most. And they were like growing degree days is the one, and then rainfall, then drought index, then corn suitability rating, which signifies the quality of the soil. Then we have the yield as a target variable, which we are using. And they were like, we don't want you to like work on the complete year, because like we grow our corn starting from the April, and so the growing season is from April to September. So you should consider your data in this region only. I mean, don't go like for the complete year and then train your model, because it will not gonna improve their yield. And the third, so discretization. So BaseNet wants your data to be discretized. So for the discretization, we are using the hierarchical discretized approach, in which we split the data into different bins. So suppose like one farmer wants to know like whether my crop, whether my corn yield will be like above 150 or less than 180 bushels per acre. So he wants like a range or like a confidence interval where his yield will fall in after the growing season. So this is why we are using discretization approach. And then we are splitting the data we are splitting data as 75% for the training, which is from 2005 to 2009. And then we have testing data for 2010. So right now we are making a 5-year model, because like we have tested the early models, like making like a 10-year model. But since like climate has changed and the condition of the seeds and everything has changed, so it's good to focus like on a 5-year or like a 7-year model, which can give you a future prediction better. So we are using Genie, which helps you in making your structure. So you can place, so as you can see, so it gives you like a temporal structure to your model. So you can place all the nodes, which says, okay, my rainfall in the month of May, my GDP in the month of May. Then you go by April, June, July. Then your final variable is the yield, which you say. Now you can make connections if you have some knowledge. So you can say my rainfall in the month of May affects my yield. So you can make a connection, or you can also like forbid connections. Like your model, you don't want your model to learn some connections also. So you can like do both the things. So when you run this simulation and you pass the data, you will get this beautiful picture in which you have your discretized bins. You have this percentage value. So now your farmer wants to know, like, if in the month of May the rainfall is in this range, what would be my yield? So when you pass this data, you will get the output at the end, which will give you like a percentage answer. So we have tested this on the counties we have and the actual data. So we have got these results in the last column. So in the next step, we wanted to know like what kind of effects we get if we gradually increase the number of parameters. So suppose like when he started planting his crop, we have only rainfall and the GDD values. So we pass this information to the model, and we get this value, which is 30% difference. But as soon as we grows in the season and we add on multiple parameters, we can see the difference. The difference comes down to 2% only. So it shows you the effect of gradually increasing or adding more valuable parameters to the model. So just to conclude, so we are trying to make a BaseNet approach to predict county-level corn yield prediction using historical weather data and expert knowledge. We have incorporated the domain and expert knowledge from the farmers and the plant scientists and the economists who are working on this project. We have also developed a what-if scenario inference. Like we can ask questions to the model: what happens if like this much rains we get in this year? And then this model also provides you with a percentage-wise bin range. Like you will get your yield in this range, and my prediction is 70% falls in this range. So, and our model gives like 80% accuracy for more than 70 counties out of 99 in total. For the future work, we are planning to get some more weather data, and we are also trying to include some other parameters which influence yield. Say it could be the seed quality or the genomics of the plants, so that we could have a good model at the end. So yeah, thank you.
Questions? Let's start from the back end over there. No. The recording, so it's good to have the questions.
Okay, it's very nice work. So the metric you gave at the end, that's a spatial accuracy. What about temporal accuracy? Because you're only using 1 year, so maybe you're lucky at that year.
Exactly. So now we have got access to the hourly weather data for the last 50 years. So now we are trying to make like how the temperature trends has been like in the last 5 or like last 10 years. So we are now making the trends out of it, like how things affect if like they are changed in the last 2 years or 3 years. So yeah, we are working on this.
Oh, I mean, what about the yield in 2011, 2012? I'm guessing the data is available.
Yeah, it's available. So we have tested on that. But now, so the main point is like the climate has changed, and people are saying it changes every 10 years. So we have adopted a 5-year model which starts from 2005 to 2010. So we will hopefully make a model which starts at 2011, 2015, 16. Then we can like predict the yield for those years in the range.
I challenge you to try 2012.
Sure. So one more point is like, so when we ran this model on 2008 data, we had like an interesting observation. So in 2008, we had flood in Iowa, and the yield dropped down to a certain range. So yeah, we have some like interesting observation out of this data. Sure, we'll try. Yeah, sure. Yeah, sure.
I grabbed the mic away from Sivan before she could pose any further challenges. All right, so any other questions? One last question.
Yes, you had a lot of spatial variation in the state. You have mentioned that you had 90 spaces. The models parameters change a lot. Does the spatial variability of your parameters change as well?
Yeah, because like so every county has a different soil condition.
The species vary as well. I mean, you have different corn types.
So it depends on the farmers, like when they grow and the kind of soil they get. So yeah. I think so.
Okay, let's thank the speaker once again. Thank you.